Very good morning. My name is Suman Ramesh. My ID number is TG20023, section 01, course BTE3212, Electronic 1 Laboratory. And today I will present my test 1 for practical test 1. Okay, alright. So the first instruction here is that handle the diode testing to ensure the diode is working fine or not. So to test the diode working fine or not, we need to use in forward bias and reverse bias to measure. And if we measure for the forward bias, we get a value, but if we measure with the reverse bias, we will receive open, which that means it says that it's an open circuit, as we know that reverse bias diode can't work in a circuit. So right, for the next, construct the basic configuration of a full wave rectifier using the electronic circuit simulator. The main component is diode, and modify your rectifier circuit with filter function. So alright, this is the main circuit for the test today, for the experiment today, which is a full wave rectifier with two diodes here, and also a resistor with 1k ohm. And the second is it's a full wave rectifier with 10 microfarad as a filter, and also here which is full wave rectifier with load, and the filter is 100 microfarad capacitor. So alright, for the next task is to measure the output after each module, diode, rectifier and filter. For full wave rectifier only, we get 66.9 volts and 66.9 milliampere. Meanwhile, for with the filter, which is 10 microfarad, is 82.9 volts and 82.9 milliampere. And for 100 microfarad, the voltage is 101.5 voltage, and for the current is 105 milliampere. So alright, so now produce waveform signal from oscilloscope for each module, diode and module, diode, rectifier and filter. So over here, this is the waveform for a full wave rectifier with load but without filter. Meanwhile, this is the waveform for with the filter, which is 10 microfarad, and this is the waveform for the full rectifier filter with filter, which is 100 microfarad. So alright, next, calculate the voltage output, ripple factor and current output for each module, diode, rectifier and filter. So this is the calculation here over here, and we can see that we receive 105.5 volts here, and ripple factor 0.5. For the filter that we use is 10 microfarad. Meanwhile, for the 100 microfarad, we get 0.05 for the ripple factor. So for the verify the calculation is that we get, for calculation we receive 105.5. Meanwhile, from the table we get 101.5, which means it shows that we get a nearest number to the actual measurement. So right, for the discussion, difference, describe the difference module, diode, rectifier and filter towards the system performance. So okay, the difference is between the diode, rectifier and with the filter is their waveform. First, we draw the stimulation without capacitor. As we use the 1k ohm resistor, we can see that it produces a half wave rectifier waveform is produced. But then when we use 10 microfarad capacitor, which is added in parallel, the waveform produced, we can see the change in the waveform, which is ripple waveform. And also when we change to a different filter, which is 100 microfarad, with the 100 microfarad, we can see that the ripple waveform becomes smoother. Let me show you. So here's the difference between with filter, without filter, and with using two different filter. So this filter is 10 microfarad, and we can see the waveform is not so smooth. And meanwhile, for the 100 microfarad, we can see that the waveform is getting smoother as we wanted. So that's for me. Thank you.